Well, good morning, good afternoon, ladies and gentlemen. My name is Chris Doran. I'm a technical sales specialist for Global Test Supply. Thank you all for joining us for our webinar via Global Test Supply University. Today's topic is going to be gas, air, and partial discharge leak detection, new predictive and preventative maintenance solutions from FLIR. During the presentation, we ask that you kindly mute your microphone. Presentation will last anywhere between 40 and 45 minutes, and we'll have a special time allotted for Q&A at the end of the presentation. We do encourage you to ask questions throughout the presentation at any time using the chat feature. And as mentioned, we'll get to any and all questions at the Q&A period after the presentation. Global Test Supply has been working closely with FLIR for many years. We pride ourselves on being a leading distributor of FLIR. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Today's webinar will be presented by Russell Hall. Russell is based in Wisconsin, has been a channel partner manager for FLIR for the past 2 years. Russell, I will turn the presentation over to you.
Great, thanks Chris, and thanks everybody for joining. Happy to be here to talk about a couple of exciting products, pretty new to the FLIR portfolio, and bringing some demonstrative value to each of you. So appreciate it, Global Test, for putting this together, and we'll get jumping into it. So the main topic of today is leak detection and predictive preventive maintenance solutions. So quick agenda, we're going to focus a lot of our time on 2 particular products, but as you guys know, our main purpose for existing is predictive preventive maintenance, helping people make better decisions. But today's agenda is going to be leak detection overview, gas detection, in particular with our GF77, and then air leaks and partial discharge, which can be accomplished with our new Si124. So we will keep rolling, but that's what we're going to be talking about today. So for some of the target users and applications, so there are over 3,300 utilities that provide power transmission and distribution of electricity throughout the U.S. And even more in North America when we look at Canada and Mexico as well. IOUs, co-ops, municipalities, right, all use power, electricity, electric generation using nuclear, natural gas, coal, renewable energy. So all of these industries or users can benefit from some of these products that we're going to be talking about today. So if you're one of these, you're definitely landing on the right webinar here. So, and just talk a little bit more. So, do you have gas or air leaks that are hard to find? Do you have gas or air leaks that you think you have but aren't sure because you can't see it? It must not be there, right? If I can't see it, then it's not an issue, right? Peace of mind. Do these potential leaks create a safety or environmental hazard at your plant? Do these leaks cost money if left unattended? And then also, do you want to find partial discharge failures? So if you answered yes to any one of these questions, again, this is going to be a good webinar for you. We'll go through these different products and how they can solve these questions. And also, we'll talk about the ROI. So how these products and how all of these things relate back to ROI, right? Your return on investment. And then, do you want to improve the reliability of your operation? So we're going to start first with talking about some gas leaks. So how do you find a gas leak, right? Because gas is invisible to the naked eye. So I can't see it. How do I find it? So with gas leaks, there's been some technology out there for some time, dating back to the 80s. And one of the gold standards back then was method 21, or using a sniffer or toxic vapor analyzer. And so when using this is an effective way. It can show you some leaks, but you have to be very precise. You have to be pointing directly right at the source of that leak to actually find it for that sniffer to calculate it. The other one is soap and water. So if you use a snoot, right? So The theory here is you get some soap, you apply it to your connector, your valve, and if it starts to bubble up with a little bit of water, if it starts to bubble up and create bubbles, then you know that there is a leak there, right? Because there's air coming out of there, there's gas coming out of there, and then it becomes visible to you. Again, very labor intensive. You got to go around, your facilities are huge, and you got to bring this everywhere with you with soap and water just to see if there's a leak. Then maybe a little more on the cutting edge is an RMLD, remote methane leak detector. So this one, at least, you can do it from a distance. You can scan a little bit bigger of an area, but it's not always going to find everything. So we've kind of moved up a little bit in our technology and you know, what it can see and what it can do and how quickly it can do that for you and address some of those questions that we've just looked at. So the development of optical gas imaging, that's what we call our lineup of cameras, OGI, optical gas imaging cameras, has revolutionized gas detecting, allowing the visualization of VOCs, or volatile organic compounds, and other gases. So there are some common challenges when you're looking for leaks. One, they're time consuming. Leak detection is not a quick endeavor. It can take a while to find a leak. It's also hard to pinpoint where that leak is coming from. So if you're outside, there might be wind or other things involved where you might see gas, you might smell gas, but you don't know where it's coming from because it's moving so quickly. And then especially around energized equipment, right? So if you have energized equipment, you think there's a leak in there, you can't always get into that spot. It's not safe to go around that energized equipment. So it's going to be even harder to find it when you can't get close up to it. It's easy to miss leaks. Leaks can happen right under your nose and you not even know them, right? Because this is gas, it might not, there might not be a smell that comes off. And again, with some of these methods where you got to check every nook and cranny, you're not always going to find these leaks that could be hiding right in plain sight. It's expensive, right? So gas is expensive. You paid for the gas, why waste it? And then environmental damage, right? So SF6 and methane, right, are not good for the environment. And actually SF6 is about 3,200 times more potent than carbon dioxide. We know what carbon dioxide does to our atmosphere. Luckily, there's not as much SF6, not nearly as much SF6 in the air, but it is way worse of a chemical or of a gas when it comes to destruction to our planet. So we want to limit that as much as we can. And then lastly, and probably most importantly, safety, right? These gas leak can cause an explosion. Similar to this picture that you see here, right? You walk through a power generation plant, you're going to see signs like this: danger, no smoking, no lighting up, all of that stuff, right? Because they know that there's gas around in that area, and if somebody were to strike a match, right, and you got methane or natural gas leaking, that could be a bad day for a lot of people, not just that one person. So we know that these issues happen, and what we want to do is go find them as quickly and efficiently as possible to make sure that these issues don't go unaddressed and don't become catastrophic failures. So another way to kind of look at this is, do you or your employees wear PPE or FR clothing? And probably most of you on this call are yes. Maybe you're in it right now, taking a break to join this webinar. But yes, so PPE is like seatbelts, right? It's our last line of defense. So, seatbelts, they're not going to prevent a car from crashing, right? You don't put a seatbelt on and say, okay, I'm not going to crash today. You put a seatbelt on to say, if I crash today, at least I have my seatbelt on. Same thing with this PPE, right? If there's an explosion or a leak or electric discharge, at least I have my PPE and my FR clothing on. So if we take this a step further, do you drive at night without headlights? Well, the answer is no, right? Probably not. None of us are going to be driving around our car without being able to see what's in front of us. So why do we do electrical work in the dark? Why are we just putting on our seatbelt and assuming that everything else is okay? Why don't we want to get a better visual of what's going on to make sure that we prevent that accident from happening? So there has to be a better way. What if you could scan large areas quickly and safely at a distance, like an RMLD? What if you can pinpoint exactly where it was coming from, like a snoop or TVA sniffer? What if you could document in a picture or a video the exact location of the leak to make repairing faster, right? So a picture is worth 1,000 words. With our various thermal imaging cameras and gas finding cameras, it's easier to comprehend, diagnose, and solve and fix these issues. So that's what we're going to look at today. Here you have a picture of a gentleman using our GF77. And that's going to be the first solution here that we talk about. So the GF77 is the most versatile camera really FLIR's ever made, and really that's on the market today. It's the most versatile camera on the market. The reason why is because it can do a multitude of things. One, it can detect methane. So it can find methane leaks in your plants, coming off of flanges and valves. SF6 detection. Now you can bring this out to your electric and your substation, your power generation stations, and find if there's an SF6 leak coming off of a connection. Also, it can do ammonia and a couple other gases as well. And then again, these are going to be common gases that are found in power generation and manufacturing plants. Lastly, it can also detect hotspots. So similar, to our FLIR thermal imaging cameras, this thing has full capability of thermal imaging as well. So we're combining both gas and thermal imaging to give you that most versatile camera that's really ever been on the market. So when we think back to that slide with all of these different plants across North America, maybe you're sitting in one right now and you don't have a tool like this, right? There's a big market for these, and again, our mission is to keep people safe, keep our environment safe, and make sure that you go to work, in the morning, you come home in the evening. That's our number one goal with why we create all of our solutions. So how does optical gas imaging work? Right? How do we actually see the gas coming out? And that's what we're going to talk just a few slides here on. Just a little bit of the technical. So the camera sees more than just gas. It sees other things, just like our naked eye would see. It sees people, it sees pipes, it sees ground, it sees plants, it sees all of that. So when you're getting this, it's, here's your detector, here's your lens, and it's not communicating, but it's seeing what's in front of it, right? Seeing what's in front of it, and it sends that image back to the camera. Now, when we have gas, this gas, it looks like smoke. It's not smoke, but it looks like smoke, or at least when you're looking at it in the lens, through the lens of the GF77 camera, it's going to appear to be smoke. And what's happening is this gas, be it methane or SF6, it's blocking some of this visible spectrum coming back to the detector. So you see the manufacturing plant or whatever you're looking at, it wants to send all of this back to the camera, but some of it is obstructed by the gas that's leaking in front of it. So that's why we see it looks like smoke, because it's actually blocking what's behind it. So it can see through most stuff, but when there's a gas that it can't see through, that's when you see, again, the quote unquote smoke, and that's when you know that you have a leak. So, there's an electromagnetic spectrum where we see things, right? We have gamma rays, X-ray, ultraviolet, visible, that's where our human eyes rest, infrared, microwave, and radio. So we tune our cameras to these particular wavelengths where gas can appear, where gas can be found. So we have a slew of cameras. The one we're going to be talking about today the most is our GF77, but we have some cameras that are called mid-wave length cameras, and then we have cameras like the GF77 that are our long-wave cameras. And that's what we have today. We're going to be talking about waves between 7 microns and about 12.5 microns. So again, here's another illustration of kind of how this works. So we match the spectral response of the camera to the peak spectral absorption of the gas. So, and this is, skewed because this is actually proprietary information that we use to make our detectors. So here you have a couple different gases, right? And here's what they transmit. Transmitting means you can see right through it. If you're at a 1.0, you can see right through the gas. It's not going to block anything. When you're at a 0.9, you get a little bit of blockage. When you're at a 0.5, you get more blockage. If you're down at a 0.0, you can't see past this gas coming through. So what we do is we find out where these gases lie is, in the spectrum and the transmission of them. And then we tune our lenses in our cameras to find, to where those transmissions are low, because where those transmissions are low, that's when it's going to appear to be smoke, because we're not seeing, the panel or the substation or whatever it is behind that. We see the smoke instead. So here's another kind of look at a couple different gases. And again, we have OGI cameras for, very specific gases. This GF77 really takes into account a couple of the main gases that you'll find on power generation and manufacturing. So again, in the spectrum of about 7 to 8.5, and then as well from about 9.5 to 12, that's where we're going to see most of our methane and our SF6, which are the primary gases that this camera can find. So enough about looking at the science of it, right? Let's take a look at a video. And hopefully this video is coming through pretty smooth. Sometimes with the bandwidth, showing a video doesn't do it all the justice that it should. But this is a leak that was discovered at a power plant. And you can see right where the leak is coming from by tracing the smoke, right? So we have a little cap right here, and then hopefully you can see the smoke kind of coming off. Chris, is this image coming through to you? I know when we kind of looked at this the other day, it was a little spotty, a little better today.
The first was coming in a little bit better, but it's still relatively clear.
Okay, perfect. So you also see that we have a couple different modes. So in this mode that it's in right now, this is our high sensitivity mode. So hopefully this is the one that's a little more clear. You can kind of see that smoke coming off. And again, this is a methane leak, and I'll just hit play on this again. This is a methane leak, and so some folks say, well, hey, we put mercaptan in our methane to give it that smell. So very odorous smell that to our human nose is gonna wake us up in the morning, right? We put mercaptan in there, so if there is a leak, we'll smell it. We'll be aware to it. And that works to a certain extent, right? But you step on, a lot of times if you're working day in, day out in these plants, in these facilities, you might be used to that smell. You might become accustomed to it. Then when you go home at night and now you're in your house, and if you have a natural gas oven, and then you smell that, that's a new smell for that environment. So it is a way to try and help alleviate some of that and to warn us, but it's not always going to be effective. And still, that smell is going to be in the air. You're not going to be able to smell it directly to a certain flange or to a certain valve as easy by just following your nose. Here's another look at one, and this one's going to go through a couple different video modes as well. So first here in our high sensitivity mode, and then here's like our normal mode, and this one's pretty thick, and then you saw it there just like in the visual mode as well. So this captures video in all three of these modes at the same time, which is great. So now if you got to send this to somebody, maybe you're doing the inspection, but somebody else is going to come do the fix, you can send them this video. They'll know exactly where it is, especially with the visual image. Now they have those, visual cues to work off of, so they know where you're at. So, again, this is an environmental hazard, a safety hazard, and dollars really that are just leaking out of your facility. And it goes back to all those signs we were talking about before, right? Like no smoking and things like that. That's the reason, because these happen, right? Things are going to happen in your facilities, and some of these issues are going to pop up. Finding them and correcting them is, you know, what we want to do as quickly as possible. Here we have a circuit breaker. So again, now this is the same camera that we're going to use as before. What you see back here, if I flip back, you'll see that it's like a little red square here, and it's the 7 to 8.5 microns. So this is the lens that's used to see methane gas, and methane gas presents itself best in that 7 to 8.5, micron wavelength. Now what you see here, when we go to this video, you notice that we got a little green square, and we see this wavelength indicator of 9.5 to 12 microns. So same camera, what we did was just swap out the lens. So this camera has multiple lenses to see multiple gases. So now when I hit play on this video, and this one's a little more difficult to see, but you should be able to see some smoke kind of coming out, that smoke look again, coming out from right at the top of this unit, and the wind is kind of pushing it this way. So historically, FLIR has had a camera designed specifically for SF6. It's called our GF306 camera. This camera only finds SF6, so it's very, very precise, a little more precise than what the GF77 might be, but it's very expensive. We're talking six figures, $100,000 for that GF306 camera. And so that's not going to be in everybody's budget. If you're working at a facility that uses a ton of SF6 and you want to find the smallest of small leaks, then you might make that investment. But if you're going to be looking for maybe bigger leaks, a little bit bigger leaks, this GF77 is going to be priced very more modestly to go and do that. Plus, it can do the methane and ammonia, carbon dioxide, and some other gases as well. One cool thing, I'll just kind of try and play this back. Maybe it's coming through. You might see a couple things that look like shooting stars coming through. That's actually bugs that are flying in the air. So this is very precise, very detailed, very powerful camera that can actually track those miniature bugs and mosquitoes flying through the air, and again, it kind of looks like a rocket taking off, if that's coming through. Lastly, again, on this camera, and you can use either lens for this, is your predictive preventative maintenance when it comes to hotspots. So here is a thermal image taken by this camera. Now in this image, there's not necessarily anything wrong with this connection, with this breaker. There's nothing wrong with it. We don't have a true hotspot, but what you can see is the detail and the clarity of this. You can see these connections being made, and if there were a hotspot right here, it would jump out. You would have a hot yellow or even white colored spot right there, and you could know that you have a problem, that you have a heat anomaly happening. So again, finding those gas leaks, doing general predictive preventive maintenance, makes this, again, the most versatile camera on the market. So let's look a little bit closer at the camera, and maybe some of the features, and kind of how it all works, how it all comes together. So first, the general features of the camera. So temperature ranges from -20, you got 3 different temperature ranges, and again, this is going to be more related to when you're doing that predictive preventive maintenance. -20 to 80 degrees C, 0 to 250 degrees C, and then if you're looking at something even a lot hotter, up to 500 degrees Celsius. These cameras come with onboard routing available, and what routing is, it's a part of software that we make that you also load onto your camera. And if you have multiple checkpoints or multiple things in your facility that you want to look at on a weekly basis, a monthly basis, or whatever it is, you want to make sure that those actually get checked off the list. You could create a route on your PC, load it into your camera, and then the camera will actually walk you step by step, say, hey, we got to do this circuit breaker, we got to check this flange, we got to check this electrical panel, and it'll take you around your plant. And because you've thought of this before and you put it into the computer, you can do it in the most efficient way possible. So instead of doing two things on the east side of the building, then going to the west side just to later find out that you forgot to do something on the east side of the building, you can have that route created for you, making sure that you check all the things off your list. And then temperature accuracy of this camera is plus or minus 3 degrees Celsius, which is pretty good for these, for these applications. We've been selling a lot of cameras lately for elevated skin temperature, right? So if you're scanning a human and you have a plus or minus 3 degrees Celsius, that's way too big for scanning a person to see if they have a fever or not. But to see if you have a connection that's too hot or a fuse panel that's too hot, you're going to see that heat anomaly. It's going to be plenty accurate for those applications. Then we have the GF77, the LR or the low range lenses. So again, this is the spectral range between 7 and 8.5 microns. The primary gas for these lenses is going to be methane. That's going to be the most common. And then secondary gases, sulfur dioxide, nitrous oxide, some different refrigerants, propane. We can do all of those gases with this camera. Comes with two different lenses, 25-degree lens, which is our standard, and then we're going to be coming out with a 6-degree lens here hopefully early next year. So with the 6-degree lens, that's going to be more of a narrow focus lens that'll help you take readings and analysis of objects at a farther distance. Then we also have the HR or the high range lens. So the spectral range is here 9.5 to 12 microns. And then again, the primary gas is going to be your SF6, your sulfur hexafluoride. And then secondary gases, ammonia, ethylene, and a few others. And then again here, your lenses are going to be your 25-degree lens, which we have today. And then again, coming shortly next year, we'll have 6-degree optics as well. So just a little bit of how you would kind of order these. So you can kind of order them a la carte. So you get the base model camera, and if you want that to be with a low range lens because you're going to be doing your methane detection, or a high range lens because you're going to be doing your SF6 detection, you can pick which one you want. If you want each, we have an option for that, or a kit built out for that. If you want 3 lenses, all 4 lenses, you can do that. If you buy one lens today and then 6 months from now you find a need for a different lens, you first got the LR lens, now you want the HR lens, you can buy that HR lens, 6 months down the road, a year down the road, send your camera in to FLIR, we'll calibrate that new lens to your camera, and then you'll have 2 operating lenses with your camera. So you can definitely make aftermarket purchases to build onto your portfolio. So hopefully you guys are chatting in some questions to the chat box. I know Chris will be taking note of those questions. But that's about it on the GF77. We have, if you want a demo unit, things like that, definitely reach out to Global Test. They can get you set up. They can reach out to me. We can get you, more information if you want more in depth or whatever you need. We'll work with you guys. So we're going to switch gears a little bit now to our Si124, which again is part of the leak detection that we're talking about. So air leaks and partial discharge are what our Si124 can do. And we're going to talk a little bit about what do those two things have in common. How can one device find both air leaks and partial discharge? And the reason is because they both produce ultrasonic sound or ultrasonic spikes. So here is a chart. It doesn't have the greatest acronym, but it's a DIP chart. So, and what it is depicting is the lifespan or the life cycle of equipment and how it degrades over time. So when you first have a new piece of equipment, right, out of the original design, you install it day one, like buying a car, a brand new car, off the lot, you expect that car to be humming around, humming 100%, right? Be perfect. I just bought it, it's brand new, it should work flawlessly. Then you have the car for a little bit, right? Or maybe install something, if we go back to like a plant, right? Maybe you're installing something to this, right? Okay, so that's a change. You still want to make sure that you have great alignment and all of that, but there's going to be some sort of change. Then you come to the P, point at which failure can begin to be detected. So with your car, maybe you need an oil change at 10,000 miles, or you your tires start to fade after 50,000 miles, right? That's a point where failure in your car or components of your car are going to start to show themselves. Maybe it's around 50,000 miles. You're hoping that your motor, your engine is going to make it 150 or $200,000 or 200,000 miles. But we know our brakes are going to have to be repaired. We know our tires and all of that. Maybe our heating and our AC are going to have to be fixed. So on this chart, you'll see that one of the first indicators of when a problem starts to occur is your equipment will start to make ultrasonic sounds, right? Pieces of that will start to fail, and it'll produce ultrasonic. Then you have vibration, oil analysis, and actually thermography is a little bit down the way on this chart. Again, you're going to have vibration in your engine or something maybe before you see a heat anomaly in it. So when you get to this F, that's functional failure. The asset is no longer able to perform its function in the way it is expected to. You hit the gas pedal on your car and it doesn't go anywhere, right? So what we try and do is find all these issues before you have that catastrophic failure. And what air leaks and partial discharge have in common is ultrasonic sounds. So what is ultrasound? It's high frequency waves. They're beyond the range of human hearing, so we can't hear them, right? Your car might be making a noise, or your equipment might be making a noise, and we can't hear it. Produced by operating equipment, electrical emissions, and leaks. It's highly directional, so sound, right, just like playing the guitar or whatever, singing, talking to somebody, sound is highly directional. If I'm trying to talk to you and I look this way, you might not be able to hear me so good because I'm looking away from you, right? Sound is highly directional. It comes from localized sources as well. You can pinpoint the sources. It provides early warning, right? So this is the benefit. Provides early warning of impending failure. And it can be part of a comprehensive asset management system. So why ultrasonic imaging? So multiple microphones allow the camera to triangulate the source of the high frequency sound because the sound is directional. So if you have a sound coming here and you have different microphones over here, those microphones, like watching, crime movie or crime television series, you triangulate, cell phone usage off of the towers, you'll find where that's coming from. So when you combine a big array of microphones, and our camera actually has 124 microphones on it, when you combine a big array of microphones with a camera, you can pinpoint the sound location on a picture. This imaging technology typically provides a 90% reduction in inspection time. So you're going to do it, that's another way of saying it, 10 times faster, right? And then imaging technologies are relatively easy to learn. So here's just a little visual, right? We have a black and white background, and then where that sound is coming from, you get this little rainbow target. So this target is telling you exactly where that sound is, where the source of that sound is, and then you can go and see if you got to tighten a valve, on a hose, or if it's a hose and you got a leak in it, put some duct tape around it or replace the whole hose. Whatever you got to do, wherever that connection is, you can go and make that fix to make sure that you don't have any more air leaking out of there. So why so many microphones? I mentioned we have 124 microphones on our imager. So the more microphones improve the ability of the camera to precisely locate the source of the sound. So similar to like pixels on your TV, right? And especially when flat screens started coming out, you have 700 DPI, 1080 DPI, what do you have? And that goes back to the definition and the resolution. So on your TV, the more DPI that you have, the better you're going to be able to see your favorite sports team play, right? You're going to have more of that detailed picture. Same thing with 124 microphones, is it's going to be able to cover a wider area, one, and then give you better, precise information of where that leak is coming from when it does find it. And so again, a little bit about how this works and what it actually is. So what ultrasonic, what ultrasound really is a pressurized leak will cause turbulence, which can be located using the ultrasound. When air leaks into air, kind of weird to say, when air leaks into the air, finding it using any other method than ultrasound can be difficult. With an advanced ultrasonic system, it can be easy. And then also the background noise, maybe you're already thinking of this. Well, I'm in my manufacturing plant, and there's loud noises, people slamming equipment, machines pounding every second. There's all these noises going on. How do we actually find this tiny leak? And so what we do is we actually filter that out. Similar to what we were talking about, the gas imaging, how we're looking for how we tune our lenses to certain gases, to certain wavelengths, we can do the same thing with ultrasound. So sound also goes off of a wavelength or a frequency. You have infrasound, acoustic, ultrasound, and you can be anywhere on this wavelength or this frequency. And so what we're looking for is, kind of like in this area is what we're trying to pinpoint your ultrasound for those, for that potential equipment starting to degrade. And this is similar, maybe you have a dog whistle at home, right? So when you blow in that whistle, you can't hear it, but our pets can. You blow that whistle and Fido's going to be coming running right back. So again, that whistle is tuned to give off a certain sound frequency that only animals can hear. So we don't have to deal with that super loud noise pitch or yelling at our dogs. We can simply blow a whistle. So different applications. There's many different applications. We're going to focus on these top three here that are kind of highlighted in bold. Electrical partial discharge, compressed air system leak detection, and then vacuum system leak detection. So these are probably the most common, but there are some others as well that are worth noting that might be the use case for you. So first we're going to look at air leaks. As we know, air leaks can be very expensive. Very expensive. Compressed air is very common, running through multiple facilities, using up electricity to keep that power coming through your hoses and pneumatic tools or otherwise, right? It's not cheap stuff. And why waste it? So when we look at compressed air systems, the Department of Energy estimates that 30% of manufacturing facilities' electricity is consumed for compressed air. So all the electricity that is being used in that facility, it's not to turn on the lights, it's not to run your computer, it's not to run your heating or whatever, it's to run compressed air, 30% of it. So it's very, very predominant usage of a lot of manufacturing facilities. And then of that energy, on average, 1/3 of compressed air is wasted. 1/3 of all the air that you use in your manufacturing facility day in and day out is wasted due to leaks, misuses, pressure drops, and overpressurization. So if you have like a pneumatic tool and it needs, a certain amount of PSI, right? And if you have a leak, then the system will give you more pressure. So if you have that leak, you're constantly having fluctuations in the pressure. So you're going to have more pressure than less pressure, more pressure than less pressure. All of this inefficiencies leads to more waste. So if we put some numbers to this, right? So based on a typical manufacturing facility, a 200 horsepower compressor running, 6,800 hours a year. That's basically like 3 shifts a day, 5 days a week is going to get you about 6,200 to 6,800 hours in a year at, let's call it an average of 11 cents per kilowatt. If that leak went the whole year undetected, you would be spending $38,532 in nothing, just in wasted air. So that's very expensive. And you could be a hero. Maybe you could use that money for, for a bonus, right? You go and find those leaks or multiple leaks. You say, hey, I just saved the company, $40,000, $50,000. And we'll talk later about how we can actually show you how much you're saving. But that's real money. And I can tell you this now that, our unit does not cost nearly how much it can save. So your return on investment with this camera can be realized very quickly, 6 months, less than a year. And it'll be the gift that keeps on giving. So the great thing about using this camera, right, it's very easy to use, it's one-handed use, is all you have to do is trace, in your facility from your compressor all the way through where air can be going, right? So you're going to have different hoses and whatnot, and see if there's any activity. And if you get an image like this, at a connection, you have a bad connection right there. You can take that image, you can save that image, and then continue on, right, to go and try and find more. These images, they go up to the cloud, and then they can be saved there. And then you can come back to this spot, after you send somebody out to go fix it. You can come back to the spot and then, scan it again. And hopefully after, somebody went and fixed it, you're not going to see this image, you're not going to see this target showing you that air is still coming out. So it's easy to check your work. It's easy to give direction to somebody where they need to do. And it's super easy to operate. All you got to do is walk around and scan your facility. You don't have to be super close to anything. You don't have to, point it right at it, right? You could be focusing on, something a foot, 2 feet to the left, and it's still going to show up that sound because we have those 124 microphones that are going to be capturing a big space. Again, here's another image of just a bad connection. And this is compressed air that's just leaking out, and again, just dollars coming out of those tubes and pipes. Now we'll switch gears a little bit to partial discharge. And similar to the GF77, this Si124 again is super versatile. It can do both your air leaks, your compressed air leaks, and your partial discharge. Here's a good image too of just what the unit actually looks like. It's a touch screen unit. So if you want to capture a photo, you just kind of hit this button. It's a decent size. It's probably about a little bit bigger than what an iPhone might be. That screen, it might about the same width, maybe a little taller. So a good screen, touch point, touch screen. So very easy to use. So with partial discharge, there's 3 different classifications of partial discharge. We have corona, which is, not the coronavirus, but ionization of fluid or air surrounding the conductor. So this is the stuff when you're walking by your power lines, in your neighborhood or, off the highway, and you hear that buzzing sound. That's what you're hearing is this corona. It's just the ionization of the fluid in the air surrounding that conductor. Tracking, so you could have surface tracking over contaminated insulation. Right, so if this thing gets contaminated, then you're going to have, this webbing effect kind of happen, which again is not good. It's going to, damage your equipment. And then arcing. Arcing is, electrical breakdown of a gas producing a plasma discharge. And this can be very dangerous, right? This is probably the most dangerous of all 3 because a lot of these are in your substations, and excuse me, a lot of these connectors are going to have porcelain around them, right? And so when you have this arcing, and if it does turn into an explosion, you will have porcelain flying everywhere, and that porcelain, this debris, shrapnel, can be destructive to other surrounding equipment. And then also, once it's flying in the air, it could be very harmful to people that might be around it, people on the ground that might be around that porcelain flying through the air. So, arcing is definitely, what we don't want to see happen, and probably the most dangerous of all three. So we'll look a little bit at, the workflow of how this camera, how you actually go out in the field and, find partial discharge. So first, you go out and you scan your bushings and your connections and all of that. You get an image and it gets sent up to the cloud. Then once you're connected to the internet, and again, this is just a web browser, then you can upload all of your images. And then there's actually artificial intelligence, AI, that is going to analyze and process this data and this information. From there, determination will be made based on the data that it collected. You can have one of three different things. You can have discharge in the air, discharge between two components. So if you have two components that are kind of close to each other, maybe it's just bouncing stuff off of each other. And then the most dangerous one is discharge internally. And again, that's going to be, it's this guy right here. So you have these different icons, so you kind of know what you're looking at, because there is going to be a certain amount of discharge that's just going to be normal. Doesn't mean that it's harmful. But once we put this into the AI to do that analysis, then we'll know whether it's harmful or not. It needs to be addressed. So here's an example of a faulty insulator. Through your scan, you might find an image and it looks like discharge that is potentially inside the component. It could be on the surface caused by a dirty insulator, if it's dirt or bird poop on it or something else. But once verified that that component is clean, then your next thought should be that, hey, this could be an internal problem, and this could be cause for concern, and we need to go fix it. And so again, you'll get that prediction, you'll get that analysis over here, and it'll say, hey, this is either discharge on the surface or inside the component. Now that you know this, if you can power down, certain transformer or whatever, at a certain time that works into your schedule, you can go do that, power it down, take a cleaner look, closer look at what's going on, and implement that fix if need be. And then again, here's a surface discharge again on an insulator. So it'll tell you, it'll give you its prediction, its analysis, whether this is discharge on the surface or inside the component. Again, maybe it just needs a quick clean and that'll, go away, or maybe it is inside the component and there's something that you want to sub out there. And then here's floating discharge. So this is what I was talking about just a few slides ago, where you could have discharge between two components. So this doesn't necessarily, raise the alarm. But again, if you see something, simply take a picture of it, right? It's not going to hurt to take a picture. You can have all of that data, all that stored. You throw it up in the cloud, so you don't have to worry about filling up an SD card. You throw it up there. If it's not an issue like you have here, discharge just between two components, then you're good, right? Maybe just make a mental note of it, but nothing else. You can delete that picture, save it, whatever you want to do, move on and check your other analysis. Here's a little look at a snapshot of the software. And again, this is web-based software. It's free. It's not an additional charge or anything like that. So basically it comes free with the unit. This is an air leak. And we have it here in looks like pounds. But this is a little bit of, you can put in different factors, right? So if you were, like we saw before, 11 cents per kilowatt, right? If that's your electricity rate, you have 11 cents per kilowatt. And this thing is going to tell you how big of a leak you have, how much, pressure or frequency is coming out, how many hertz of that is coming out. And then it can calculate, okay, this thing is on, 16 hours a day, 5 days a week, and it'll calculate, the cost of this leak, right? So this one, just 20 pounds per year, not a substantial amount, but maybe you have, 10, 20 of these, 50 of these. Maybe one of them's a lot more than 20 pounds per year, $20 per year, or whatever. But you go and find these leaks, you correct them, you're going to save that money. You can also access this on your mobile device. So again, you can, kind of go through there. You can, share these, and multiple people can log on to the same camera, so everybody can be working off the same sheet of music, and you can get all that analysis as well right on your camera, or excuse me, right on your mobile device. Lastly, we'll just look at some features. So again, most important, it can do both air leaks and partial discharge, giving you the versatility to do a lot more in your day. It's lightweight, portable. It's only about a little over 2 pounds. Can be operated with one hand. The operating range is anywhere from 1.5 to 50 feet, all the way up to basically a football field's length, 100 meters. So it can find things from a big distance, give you an indication of where that sound is coming from. It has both built-in plus external replaceable battery, allowing up to 8 hours of operating time. So it can definitely get you through a full day's work. If all you're going to do in a day was scanning, you could do it, without having to take a break, without having to go pause and charge any batteries. It has Wi-Fi built in, so again, you can access that right from your mobile device if you like. Boot up the the software, and you can be doing it right in your hand as you're doing this. It's a 5-inch color display. So again, touch screen. The operating temperature, 14 to 120 degrees Fahrenheit. So really, it can, if you're going to be outside and you're going to be doing something, whether you're in Minnesota or Texas, you can definitely use this device in any environment. And then pricing, it's right at $20,000. So again, finding some of these different leaks, you can see that return on investment, really surpass within 6 months or a year of buying your unit. And then it's the gift that keeps on giving. The next year you continue to find more leaks. Now you're just pocketing that money and running your facility that much more efficient. So with that, I'll open up to any questions that you guys may have typed in to Chris during the background.
Perfect. Thank you very much. Thank you for the presentation. Lots of information, a lot of details on both options. We have a few minutes for questions, so please, a reminder, please use the chat feature to get them in. If we're not able to answer them in the time that we have remaining in the webinar, we will take them offline and answer them directly. So we talked about the cloud and how the Si124 is can be used with the cloud. Can both these cameras be used with FLIR tools or Studio?
Good question. So the Si124 is just going to use that web-based. It's not going to be connected to FLIR tools or FLIR Studio. But the GF77 absolutely will work with the FLIR suite of software, whether it's FLIR tools or Studio, Studio Pro, any of those. And again, like I mentioned as well, it does have the route creator built into it. So that route creator helps you plan out your day, make sure that you get all of your critical assets throughout your facility, ensuring that you get those scanned.
Perfect, thank you. What's the calibration cycle like for these cameras?
Good question. For the GF77, most of our thermal cameras, they're around 1 year. You might want to go and get them calibrated. We typically say 1 year. We see a lot of folks, generally stretch it to 1.5 or 2. But our standard is 1 year. On the Si124, Chris, that's a good question. Let me follow up on that, or if you could shoot me a note. I'll have to check out the calibration cycle on that one. I don't have that off the top of my head.
Absolutely, no problem. Can the GF77 indicate what type of gas has been found?
It cannot. So all the gases again will appear as that smoke. You'll kind of know, determined by the lens that you're using. But as a slide that I showed, and maybe where the question stems from, is that it can find multiple gases. Even each lens can find multiple gases. It won't be able to tell you which one it is, but hopefully you can track, that pipe down, and maybe there's a label on that pipe that it's methane or natural gas or ammonia or whatever it is coming through. But all the different gases will appear to be the same, just like a smoke look to it.
Okay, perfect. Another question we got in was, are there any specific training or certification available for both use of the GF77 and, I guess, within the industry, as well as the Si124?
Great. Yes, there is. So we have a part of FLIR is called ITC, Infrared Training Center. And it's prominently displayed on Global Test as well. So what ITC is we have level 1, level 2, level 3 training for thermography. So, started as thermography, but as we've come out with more and more solutions, we've expanded our training and the different classes and courses that we offer. In this time of COVID, a lot of these you might find as like a virtual class, or like you could even do like a self-paced, on-demand tutorial. And then we hope to, kind of get back out in front of you guys, and we have online or in-person instructors as well. So, yeah, definitely you can check out itc.com or go to Global Test as well and search. Chris, I think you guys have like a training section at the top of your ribbon where you guys can find ITC there as well. And we do have specific classes for, like OGI, optical gas imaging, and Si124 as well.
Perfect. So yes, as a follow-up to any all that are interested in the training, the schedule, costs, etc., all of that can be found under the training header on globaltestsupply.com, as well as any questions about, I know we touched upon pricing with both of them, but pricing, availability, rentals, demos available, any and all. You can go to our website, globaltestsupply.com. You'll find our email address to email one of our inside sales reps. You have the live chat function as well. So we have just under a minute left, and to be respectful of everyone's time today, we didn't get too many more questions that came in. All the questions that we did come in that we didn't have a chance to answer here live, we will follow up with you directly post the webinar. And if you do have anything after, please feel free. globaltestsupply.com, our website, our email address, and our contact info can be found there. So Russell, thank you very much for the presentation. A lot of information. I know there's going to be plenty of people who were very happy they tuned in today. So thank you very much once again.
Absolutely. Yeah, thanks for hosting, Chris. Hopefully you guys found this informative. Definitely reach out to Chris. We have some demos available if you like to try demos, and in particular on the Si124. We get some demos out to you guys. Let you play around with it. For a couple of days. So definitely reach out if you have any more interest or any other further questions, and we'll definitely address those.
Perfect. Thank you once again. So yes, on behalf of Global Test Supply University, thank you for joining us. We do certainly hope that you found it informative and helpful. We are here to assist you in any way. As I mentioned, please go to globaltestsupply.com. You can find our contact info, all pricing, availability, the training header for more information about that. And you can contact us directly for any follow-up questions, technical or anything along the like. We can answer you there. At the end of this webinar, we'll have a very short survey that we'd ask you to complete. Your feedback will assist us in improving this forum and these webinars, as well as bring you topics that you are interested in. Don't forget that as a thank you for today, for attending today, your name will be entered in a draw to win $100 towards your next online order. The winner will be announced on our social media channels, so please be sure to check us out there. Once again, Russell, thank you very much. Thank you all for attending today, and we'll wish you a great rest of the day.
Thanks, everybody. Thanks, Chris.
Thanks. Take care.